younger generations like mine, or some people who are younger, they've never seen these lands in a better shape. So this is where you bridge the generational gap between the elders and the youths. The elders will tell stories that this river used to have fish, we used to swim in this stream, we used to have clean water from this stream to drink. And the younger generation has never seen that before.
It's microbial based. It's amazing, isn't it, that the most influential organisms on the earth are the ones that we cannot see.
Our lack of respect and ignorance toward animals has harmed them. But what we don't realize is that if they don't survive, then we won't survive. We cannot survive without the animals that build up our ecosystems, and their demise will ultimately only lead up to ours.
As the temperatures flare, carbon filling the air, will we survive the fall? Will our history repeat, or will we plant the seed to rise above it all? And the phone starts to ring. Are you listening? It's 2 minutes to midnight. Only 2 minutes to midnight.
1 billion people still don't have water, safe water. 3 billion people don't have safe sanitation. Over 8 billion people will be living in urban concentration camps we call cities by 30 years' time. And really the pandemic disease consequences, if we don't manage our hydrology, if we don't manage the water in those situations, is horrendous.
Now, my favorite example of how coevolution can do this is you can start right off with something like a predation, what that fungus was doing to American chestnuts, and it can co-evolve all the way up to a mutualism where both parties not only benefit, but have to interact to benefit. And so my favorite example of this involves 2 species that aren't around here. They're down in Central America. But one of the species is the bull's horn acacia tree, and the other is its resident Azteca acacia ant. And through their co-evolved time together, the acacia tree has developed 3 features to service its ants. The first is the thorns that used to ward off herbivores have become really huge and pliable and swollen, and they don't protect the tree anymore, but the ants drill into them, hollow the thorns out, and then that's where they raise their young. Secondly, on every leaf stem are these open nectaries or sap wells where the sap just comes out of the stem and the ants go and drink it, and that's where they get their carbohydrate energy resource. And then finally, around the margins of every leaflet are these little globules called Belchian bodies, and the ants harvest them for the nutrition, and then they grow back. Through their co-evolved time together, the ants have become so specialized on the acacia, they can only eat acacia sap and Belchian bodies. And if they're removed from a tree, and even given all sorts of other food items, they'll starve within about a day's time. But in return, they give their host trees the most advanced plant defense system in the world. They have a very venomous sting that will ward off all herbivores, so these trees never get munched on at all. But not only that, if vines try to crawl up an acacia tree, the ants will come over and they'll chop those vines down and kill them. If a surrounding tree starts to move in the acacia's space, the ants will go down off their tree into the surrounding tree and defoliate it. If you remove the acacia ants from their host tree, it'll be dead in about a month's time. But what's wonderful about this example is we know from the mandibular structure of these ants that they're derived from leafcutter ants. So way back when, whenever the ancestral leafcutter ant and the ancestral acacia first came together in a young ecological interaction, was probably not a very pretty scene. Trees might have been being stripped of their leaves and killed, a very energy inefficient thing to do, and somehow natural selection urged them into this current mutualism where they both have to interact to survive.